Okay, so at the end of the last lecture, I left you guys a question, right? Can you write the mass balance and charge balance equations for the following systems, which has 0.01 molarity of ammonia, that is saturated with silver chloride compound, okay? And at the end of the class, I mentioned about all those three possible reactions going on in the system, right? All right, so now can anybody let me know what is the charge balance equation for this one? What ions do we have to put in the equation? Right, start with putting all the cations on one side and all the anions on one side. So on other side. So what do we have here? What are the ions available in the solution? We have silver, yes. And we're looking for the positive signs, right? So we have silver, ammonia, complex ion, ammonium. Plus NH4. Is there anything else for cations?
No.
I think that's it.
Think again, please.
Oh, hydronium ion?
Yes. So
From
we also have hydronium ion. Or you can write H3O. It's the same thing. All right. So this is the cations. What do we have on the other side? We have
chlorine ion.
chlorine ion, and hydroxide. Right. So
Yeah.
yes, that's right. So what you put in the chat box is correct. That's our charge balance. Right? What about mass balance? So mass balance starts with what you put into the solution. And we have two parts, right? We have the 0.01 molarity ammonium, and we also have silver chloride, although the amount of silver chloride is unknown, but we know it's an insoluble compound, so there will be very limited amount of silver and chloride ion both available in the solution. Okay. So let's first think about the ammonia part, right? Basically, the mass balance means that everything you put in, the total amount you put into the solution should equal the total amount of all forms of that species, right? So in this case, we should have, the first one is the 0.010. This is the total of all the ammonia species, right? So this should be the sum of all the possible forms of ammonium in the solution. What are all the possible forms of ammonium in the solution? So if we're looking at the possible reactions going on, ammonia, ammonium,
Silver,
then we have
ammonia, and ammonium.
this one, and this one, right? This complex ion also has ammonium inside. So we have three different forms, which means that we will write them like this. Anything missing here?
Is it number 2 in front of the complex?
Yeah, you're right. We have 2 ammonia here from this complex. So what should we do with it?
Coefficient?
Coefficient, yes. We have to put a 2 before this one because every 1 mole of this complex ion will contribute 2 moles of ammonia. Okay, so this is actually our first mass balance. The second mass balance deals with silver chloride. So the idea is all the silver and all the chloride comes from the same compound, right? So the idea is the silver total should equal to chloride total. And when we look at all the possible equations, chloride seems to be all by itself. It doesn't form any complex ion, but for silver part, it actually forms a complex ion, right? So the total amount of silver should be silver ammonia, and these two add up should equal to chloride. Does that make sense?
Yes.
Because silver and chloride, they come from the same compound. It's always 1-to-1 ratio, same amount of silver dissolved, same amount of chloride dissolved. And that's why when you count the total amount of each, they should be equal to each other. Okay, so that's a review for a systematic treatment of equilibrium. Do we still have any questions here?
Yes, Professor.
Mhm.
Do you also need a 2 in front of the sodium? Silver?
This one?
Yes.
No, we don't, because we only have 1 silver here, right?
Oh.
So every 1 mole of the complex ion only contribute 1 mole of silver.
Okay, thank you.
Yeah, no problem. Okay.
Hey, Professor, I have a question.
Yes.
For the NH3, like there's a 2 in the front. We don't need to put that as the power, right?
Which part are you talking about? This
2
one?
NH3?
This one?
Yeah.
No,
Need to put the 2 as exponent? No.
No, we don't. This is just in this reaction, but in the solution, ammonia itself contribute 1 more ammonia.
Okay.
So there's no 2 before it. Okay,